Welcome to the viewers. Myself, Yuvan Barathi, and my teammate Jaikishen have worked on our final year project titled as Anomaly Detection of ECG Signals. We feel motivated to undergo this research due to the alarming rate of deaths caused due to cardiovascular diseases. Constant monitoring is needed to diagnose these conditions, which are most oftenly spontaneous. Automatic detection of certain diagnoses will serve to be helpful for doctors to diagnose certain cardiac conditions. Our goal is to develop a certain number of combination techniques of 12 lead ECG signals, which will be helpful in highlighting the significant feature for each diagnosis. Furthermore, we will be extracting necessary features from these combined ECG signals, and we'll be using these features on certain machine learning algorithm to find out how they perform. As mentioned earlier, we'll be choosing certain type of diagnosis for our project purpose. We have chosen 4 types of diagnosis, such as right atrial enlargement, complete right bundle branch block, complete left bundle branch block, and septal hypertrophy. We extracted 75 records, out of which 20 belongs to RAE, that is right atrial enlargement, and CRBB, that is complete right bundle branch block, CLBB, and that is complete left bundle branch block. These 3 branches contain 20 records each, and septal hypertrophy consists of 15 records. So that makes 75 records. We'll see how to apply the combination techniques and feature extraction on those 75 records. This function is for loading the raw data from the CSV file as shown earlier. And this function is for FIR filtering. And here we have extracted the CSV file as shown earlier. And here using the function which I displayed now, we are extracting the raw ECG signals. And using the FIR filtering function, we are performing the filtering for all the 75 records. So the combination techniques which we'll be using are these 4. The C1 combination, which is solely designed for right atrial enlargement, that is RAE, consists of this technique. And C2 is this technique. And the supporting criteria for C2 is to find whether the ECG signal has a M shape in the QRS portion or not. The C3 technique is this, and the C4 technique is this. So these are the 4 combination techniques, or rather formulas, which we'll be using. The first function, that is the first loop, is for the combination one, which I showed earlier. So this will be done for all the 75 records. And then visualizing the TP values, TP, FP, TN, FN values, we can see that the first row, that is true positive, is 18 out of 20 records, which means 2 is only not detected as desired diagnosis. And running it for the second combination technique. Here the TP, FP values turn out to be 17 out of 20 records are detected perfectly as the desired diagnosis. And running it for the third combination, the TP, FP values are observed to be 20 out of 20 records are diagnosed perfectly for the desired diagnosis. Now performing for the fourth combination. The TP, FP, TN, FN values turn out to be 12 out of 15 records are being perfectly diagnosed for the desired diagnosis, that is septal hypertrophy. The C1 indicates right atrial enlargement, C2 indicates complete right bundle branch block, C3 indicates complete left bundle branch block, C4 indicates septal hypertrophy. Then we'll be storing the features list in a CSV file. So these are the features that we have extracted from the combination techniques. The first 2 columns are ECG ID and patient ID, which is nothing but for identification purpose. And the next 2 columns are age and gender, which are some metadata. And the next columns will determine the features that we have extracted. We can now proceed in applying the algorithm on our features. So this is the declaration of the necessary files or libraries which will be required. Here we are calling the CSV file which we used for storing the features. Here we are dropping the unnecessary columns. Now the data frame has only the features which will be required for machine learning purpose. The possible decision for the diagnosis are the 4 types of diagnosis which you have chosen for our research. Now choosing the variables from the data frame for the classification of diagnostic targets. Now we are splitting the data into training and testing with the test size as 0.15. Here we are using random forest classifier for our classification purpose. After the prediction, we are seeing how the test data has been predicted to be. And the model accuracy turned out to be 91.66%. So this is the confusion matrix for our classification done above. And now moving on to the classification of arrhythmia. Here we are choosing only the first 2 columns, which will be enough for deciding which type of arrhythmia the patient has. And the same process like training and testing splitting with the test size as 0.15. Possible decisions are these 6 types of arrhythmia targets. After applying the trained rainforest classifier, we get the prediction values to be the types of diagnosis which I have shown earlier. And the model accuracy turned out to be 91.66%. And this is the confusion matrix for the prediction done above. Now we are more eager to move on to the future part of our project, that is acquiring real-time ECG signals and using it in our combination techniques and algorithms. We tried to acquire signals using the single LED ECG module, that is AD8232, which will give us analog output, and we feeded the analog output to MCP3008, that is an ADC, and we'll be trying to post the digital signal on a cloud platform. What we are seeing here is the functions and programs we used for the acquisition and the monitoring. These are the header files which we'll be using. And I have used my own Wi-Fi and password. And this token is the token for Ubidots Cloud, which I have used here. And the variable name here is sensor, and the device label is ESP32, which is the ESP32 here is the device name, and sensor is the variable name. The setup function consists of connection of Wi-Fi. The loop part consists of first trying to establish an MQTT connection. Then after establishment, the data is obtained from the module specified. After once the conversion is done, the data is posted into the clouds. Now that I have plugged in the device, you can see the device is active now. So it is done. And in the serial module, you can see it's waiting for Wi-Fi. Once it's connected, MQTT is established, and the data starts to be published on Ubidots Cloud. So the data is 0 now because I haven't connected any leads to my body. So as I'm recording the video, so it won't be favorable outcome for the ECG signal. You can see the data being reflected here. Once we refresh every time, we can see the data being reflected here. It is 0. How the signal looks like once we connect the leads to the body. I took these readings while having the leads connected to my body. Having taken for 10 minutes, this is the ECG that I acquired from my body. Thank you for watching the video till the end. I hope I have conveyed my objectives clearly throughout this entire video. If there is any suggestions that you wish to give to me on the research purpose, you can drop down your suggestions in the comment box. And once again, I thank you for watching the video till the end.